Congratulations! You found a very interesting video introducing high dynamic range image and videos within 10 minutes to you. Now enjoy your journey.
High dynamic range has been a very hot topic these days. We can see HDR almost everywhere related to the same quality. Actually, you may already be using HDR, but you didn't notice it. For example, many mobile phones have the HDR mode to help the user take a better photo. Netflix and Warner Brothers also announced that they will start HDR filming since 2016. The television in your home may also take its supporting to HDR as a selling point. Now we will come close to the HDR stone and show you what is HDR, how HDR works. You may have the experience that's trying to use a mobile phone to record the stunning scene, for example, sunset in front of you. However, the result is usually disappointing. The reason is that the human visual system is too powerful. The brightness we can see is from 10 power minus 6 to 10 power 9. However, the traditional camera and image processing technology can only show very limited range of the brightness.
To make the display on our screen in HDR mode is a huge project which contains HDR creation, storage, and display. Now let's check how the creation works. There are two ways to create HDR content: photography and computer graphics. Let's see the comparison between the same image with and without HDR. We can see that this image can show the details in both the light and the dark part. If we want to produce the HDR image, we need multiple images with different exposures. Since a single image has its fixed exposure, the dynamic range of the scenes obtained by a single image is very limited. It's necessary to recover the actual luminance data of the actual scenes by multiple exposures, thereby obtain an HDR image. This is an example of 4 standard dynamic range images that are combined to produce a high dynamic range image. Maybe you will ask, what should we do to combine these standard dynamic range images? Before answering the question, let's see the general digital imaging process. Through a series nonlinear operations or mappings, the scene's radiance is transformed to digital images with their own grayscale value, which represent the exposures. There is a nonlinear mapping between image data and the scene's radiance, which we call camera response curve. The camera response curve can show which part of the image should apply high or low illuminance. For example, we can calculate the camera response curve with multiple images of different exposures to recover the scene's radiance, and the HDR imaging can be obtained. This is the diagram to obtain the HDR image using the digital images with different exposures. Nowadays, almost all the photography devices support HDR mode, using the similar method to show more details in the image. Many game producers also use HDR rendering to make the game scenes more realistic. Okay, how to storage HDR file in limited bits to minimize the loss is also a big issue. There are 3 main formats to store HDR files: OpenEXR, Radiance RGB, and FloatT. The key idea is using slightly more bits than normal formats. Also, the float number with some bits to represent the exponential levels is to make a higher range. In reality, there is always a problem when viewing HDR images. Many of the image display methods can only display images with a limited dynamic range, which means you cannot view the HDR images from printer, CRT, and even some LCD. Before providing a solution, let's recall the dithering we have learned in the lecture. If the hardware of display screen cannot support the high-quality images, we can apply the noise to make it more acceptable by human visual system. The tone mapping is also a similar technique. Tone mapping is a technique that can convert the HDR image into an image that can be viewed in a medium that has a limited dynamic range. For example, This function is a simple global tone mapping filter. This function will map the luminance Vin to a displayable output range. Actually, this image we have seen in the previous example is the HDR image after the tone mapping. That's the reason why we can still see this image in this video.
Both TV HDR and HDR image have the same aim, make the digital version of reality more like what we see in our real life. However, they still work differently. TV HDR is an important display process. It requires the TVs to recognize the HDR content and display it properly. While for HDR in image, the essential process is capture. Combine multiple images with different exposures to create an effect that looks more realistic. In TV HDR, just the TV's contrast ratio and the color plate are expanded. It makes the bright parts really bright and keeps the dark parts dark. This is the change of color we display on TVs in the history. The whole graph is the range of color we can see in the real life. Every triangle is a range of color displayed on the TVs in a certain form. With the time flow, we can see more and more colors on TVs, and the widest is in HDR. Not only the colors, the luminance range is also wider. If we try to present the range in 3 dimensions, we can see the range of HDR covers and cover more than the standard dynamic range. Except more details, information, and more proper color in images, the beautiful feature is another reason people like HDR images. But how we can get a HDR image if we just have a single image, or at least something like HDR image? Therefore, besides the true HDR, we also have something called fake HDR. If you search on YouTube, you can find many small videos like this. As you can see, even just with Photoshop, we can still make the images as colorful as HDRs. Nowadays, there are even some apps to make fake HDR images. With carefully adjusting grayscale, histogram, and carefully choosing filters, the result of HDR is still pretty good, as you can see. At present, HDR has swept through the video and image industry despite some format disputes. More and more HDR content and equipment are popular in the market. HDR is making the world in our screen more and more realistic.
等一下，这什么东西啊？什么？
这个
怎么读？我想读什么读什么，不是我写的。
剪掉了。
要开录制，我要点录制。